Okay, in this video, we're going to discuss about the DC machine as a motor. Before this, we have already discussed about how do we start the DC motor. So when we start the DC motor, as you can see in the previous slide, the speed will be increased up to some time. It will achieve the steady state speed. So initially, when we start the motor, we will draw a lot amount of current, a considerable amount of current, and the current will be decreased up to some time, so until it is zero. And at the same time, the speed will be increased up to the steady state speed. Now, what happens if we put some loads to this bar? Means that if I have a DC motor like this, I want to put loads. I start the DC motor up to a steady state speed of the shaft. So the shaft is turning until some time I have the load. I put a load here. So in this concept, uh, since after starting the motor, it will move the bar at steady state speed. So in this case, when I put the load, of course, the load will be opposing that the force acting on that bar. So the original force is to the right hand side. I put the load is F load, which is to the left hand side. So when I put the load, of course, in this case, the speed will be reduced, and the force induced also will be reduced. So in that case, when I put a load opposing the direction of the motion, the bar is initially at steady state. When we apply the force, the load, there is a net force acting to that bar. So the net force is uh, the the load force minus by induced force. So we can we can say that the net force is to the left direction lah, to the direction similar to the F load. In that case, when we put the F load, the acceleration will be reduced because the speed is reduced. In this case, once the speed is reduced, means that the induced voltage is also reduced, because you know that from the equation E induced equals to VBL. Once the speed is reduced, induced voltage is also will be reduced. When the induced voltage drop, the current flow in the bar will rise. So that's the behavior between the induced voltage and the current. If the induced voltage is reducing, the current will be increased. On the other hand, if the current is decreasing, means that the induced voltage will be increased. So in this case, using this equation, current will be increased because of the decrease of induced voltage. And if the current increase, means that at the same time, the force also will be increased. This is because using this equation, F equals to ILB. So since the current is increasing, the force is also increasing. Final result, the induced force will rise until it is equal and opposite to the load force, and the bar again travels at steady state condition, but at a lower speed. So in this case, the motor will be operates at a lower steady state condition lah. So of course lah, the no load condition of motor will move the shaft faster, mean at the speed higher. But once we put the load, the shaft will be moving at steady state, which is the speed is lower than the no load condition. So this is the graph that shows the behavior of the DC motor. So in this case, the speed is reducing because we put the load. When we put the load, the speed is reducing up to steady state condition. Similarly, the induced voltage will also be reduced because of the increasing of current. So induced voltage will be reduced up to the steady state condition with load. This is the steady state condition with load. This is the steady state condition with load. Similarly, the current is also increasing, increasing up to some time it achieves the steady state condition. So now there is an induced force in the direction of motion and power is being converted from electrical to mechanical to keep the bar moving. Okay, so in this case, we can consider that the power conversion is happen in that motor, which is the conversion from the electrical power to the mechanical power. So electrical power P convert ni sama dengan E int I. And then the equation for mechanical power is F induced force times the velocity. So in this case, an amount of electric power equal to E in I is consumed and is replaced by the mechanical power. Okay, the power can be also calculated using the torque, induced torque with the angular velocity, angular speed lah, right? So this is the equation that relates the power of the motor. Okay, now I'm going to talk about the DC machine as a generator. In the DC machine as a generator, we assume that the linear machine is operation under no load steady state condition. A force in the direction of motion is applied. So previously the direction of motion is to the right hand side. So now we put a force to the direction of motion. Mana we apply force ke arah ni juga. Okay. So what happened is the applied force will cause the bar to accelerate further in the direction of motion and the velocity v will increase. When we apply the force to the direction to the right direction, similar to the velocity v, this force will increase the speed. So once v increase, the velocity increase, we know that if the velocity increase, there is further increase in induced voltage. So it means that using this equation, induced voltage will be further increased because of the increase of voltage. And after some time, induced voltage increase because of the increase of voltage is larger than the VB, larger than the source. Means that the induced voltage is larger than the source. So in this case, E int is larger than VB. So if E in is larger than VB, means that now the current is flowing to the reverse direction. So that is the concept of generator. So we increase the force to the right, to the direction direction of bar, the direction of bar moving at speed v. So the increasing speed will increase the induced voltage using the equation FVLB. And if this induced voltage increase up to the level higher than the VB, means that there will be reverse current flowing in this circuit. So since the current now flow up through the bar, it induces a force in the bar. Now the current is flowing to up direction. It will induce force, this force, induce force in the bar to the left. So the induced force can be calculated using ILB. So I is the current in reverse direction tadilah. So induced force, this force oppose the applied force on the bar. Of course, as you can see in the circuit, the induced force is now opposed to the force applied to the bar. The end result, the induced force will be equal and opposite to the applied force, and the bar will move at a higher speed than before. The linear machine is now converting mechanical power to the electrical power. That is the concept of generator we convert the mechanical power to the electrical power. The mechanical power yang kita maksudkan adalah applied force ni. Kita tambahkan mechanical power ni menyebabkan induced voltage ni bertambah, dan current akan mengalir melalui reverse direction. So ini adalah bagi case current yang mengalir in reverse direction lah. E induced times I is the power generated because of the induced force ini. So the amount of power converted is P conv equals to tau in omega. Maknanya we can use this the torque with the angular speed of the rotor ataupun shaft. We can calculate the power of the converter. The same machine acts as both motor and generator. The only difference is whether the external applied force is in the direction of the motion. If the applied force is in the direction of the motion, we call it as the generator. Or if the applied force is opposite to the direction of the motion, now we call it as the motor. And electrically, if the induced voltage is larger than the supply voltage, means that the motor, the system works as the generator, the machine works as the generator. If the induced voltage is smaller than the supply voltage, means that the machine works as a motor. Whether the machine is a motor or generator, both induced force, which is the motor action, or induced voltage, generator action, is present at all times. So depends lah, motor can work in both, whether to work as a generator or as a motor. It depends on the load we apply to the shaft. So nanti semua ni boleh baca lah. Okay. Dan seterusnya saya nak pergi kepada starting problem with linear DC machine. We consider the circuit with some values of the supply source, resistance, and length of the bar, and the current flowing inside this circuit. So this machine is supplied by 250 volt DC source, and internal resistance R is 0.1. So this is the internal resistance. At starting, the speed of the bar is 0, means the induced voltage is 0. E in equals to VLB kan. So E in is 0 because the speed is 0. The current flow at start is I start. I start ni, current flowing at start, we can estimate using this equation, which is VB, the supply voltage divided by R lah. Okay, so at start, we can see that there are huge amount of current because of the internal resistance. So internal resistance ni biasanya ada dalam bateri, ada dalam coil dan sebagainya lah. So the small amount of internal resistance we cause a huge amount flow of current, which is in this case is 10 times in the excess of the rated current. Adalah rated current tu adalah 250 ampere, tetapi they increase up to 2500, which is this is a large amount of current. To prevent that large current, dia panggil high current insert, we need some extra resistance, which is the starting resistance. Which is the function of this starting resistance. Start resistance is to limit the current flow until induced voltage is built up enough to limit it. So kita tak nak lah current ni terlalu besar sehingga motor tu rosak. So that is why we put the start resistance to limit the flow of current. So start resistance is a must because we have the internal resistance. Okay, this is about the start resistance lah. So I will finish this video because it will reach 15 minutes now. Okay, Assalamualaikum warahmatullahi wabarakatuh. So berakhirlah topik ni ya.